Hi, so let's look at this question here, which was taken from the year 2019 paper on question 9. This is the actual A-level paper. So you're told to actually express y plus 1. Okay, so you're told that w could be expressed as cosine theta plus I sine theta. Okay, so for part IA, you're told to show that w plus 1 over I is a real number. Okay, there are a few ways of doing this. So the first thing is you could actually just let w equals to ei theta. Okay, because the modulus of w here is 1. Okay, so you could tell that this is 1 because of this whole thing here, which is 1. So I'm just going to leave this as 1 first. That's the most important part. Then after which we're just going to let w plus I show that. So I'm going to start off with by changing this to exponential form because it's easier for me. So I'm just going to leave it as ei theta, 1 over ei theta. Okay, so once this is done, what I'm going to do is actually just going to put ei theta here plus e minus I theta, and then I'll change to the Cartesian form. Okay, Cartesian by using the trigo form first. So this is cosine theta plus I sine theta for this over here. Whereas for this one here, what you can get is actually cos negative theta. This is the argument, right? The argument here is actually negative theta. Then the modulus, like I say, right, this one here is actually a modulus of 1, so you can just leave it as it is. So this is plus I sine minus theta, and what we're gonna get is actually just we know that sine minus theta is actually minus sine theta, right? So this is a very important property that we always use, and also cosine negative theta is actually cosine theta as such. So once we're done with that, we're just going to put cosine theta plus I sine theta plus cosine theta minus I sine theta. There you go. So this will be 2 cosine theta. Okay, so 2 cosine theta would then be here you go, this is real, so hence w plus iw is a real number. Okay, since imaginary part of w plus iw is equal to 0. Okay, you can just write this out. So this is how you do the part 1, part IA. Let's look at part IB. So you're told to show that w minus I can be expressed. So I'm going to start with that. W minus 1, w plus 1 can be expressed as k tangent half theta. Okay, great. So let's see how we can do this properly. Now the first thing is to change this to exponential form. So I'm going to put w minus 1, w plus I. Change this to ei theta minus 1 over ei theta plus 1. So typically what I will suggest students to do is to look at the argument, the angle. Okay, the angle of what you want to show. You want to change this to half a theta. So what you're going to do is actually just going to multiply this with e theta minus half. Because it doesn't matter, this we will multiply it in. So theta minus half a theta will be theta over half a theta, and minus 1 times minus theta will still be half a theta. So I'm pretty okay with that. I don't really need that to be like a strictly positive half a theta, but as long as I have a half a theta in the argument, be it positive or negative, I'm fine. So this part here, once done, I'm just gonna get e minus theta over 2 minus ei negative theta over 2 over ei theta over 2 plus e minus half theta over 2. So just multiply them in and you'll get this expression here. Okay. Yeah, this is 1. Now once this is done, what we're going to do is actually just going to just express this in cosine theta. Okay, cosine theta I theta there. So let's see how we can do that. Okay, show that. Okay, can right, so this is done. What we're going to do is actually just going to be like cosine theta over 2 plus I sine theta over 2 minus cosine negative theta over 2 plus I sine negative theta over 2. And this will just be cosine theta over 2 plus I sine theta over 2 plus cosine negative theta over 2 plus I sine negative theta over 2. There you go. So once this is done, what we're going to do is actually just simplify. This is positive cosine theta, so cosine theta over 2 plus I sine theta over 2. This is a very common expression that we always use, right? For our trigo ratio here. So you have to know this, okay, before going to the exam. It's actually something to do with the quadrant. So this, any comments, question, please let us know in terms of how do you remember this expression here. So I've gone through quite often in class, so you should be able to know this. Plus, so this will be 2 I sine theta over 2. The one below would just be 2 cosine theta over 2. And this will just be I tangent theta over 2. Okay, shown. K is equals to 1. Let's look at question 9 part 2. Part 2, you are given that actually, for 9 part 2, you are given that actually mod z equals to 1. And that you're told to find modulus of this complex number here, which is 1 plus 3i z. Okay, now what I will suggest is this is a 5-mark question, I believe. Yeah, so how do we do it? There are a few ways of doing it actually. So we just write down what we already know. We know that mod z equals to 1. In other words, if you let I'm just going to let z equals to a plus bi, because I mean, if I were to use exponential form, this is going to be a bit difficult. So I'm going to let a plus bi, but because a plus mod z is 1, so I know that modulus of a square plus b square is equals to 1. So right away I know that this likely is going to be what do you call it? Manipulation question, right? So try your best to see whether we can manipulate this part here properly. So I'm just going to do this part, modulus of z minus 3i over 1 plus 3iz. Okay, so this case here, I know that a is actually z is a plus bi minus 3i, and this case will be 1 plus 3i a plus bi. Okay, once it's done, we are just going to try and see whether we can manipulate this part here. So the real part and imaginary part, actually the modulus, just leave it outside this part. Okay, so the real part, the real imaginary part, so a plus b minus 3i over 1 plus 3ai minus 3b. Okay, just be mindful of the expression b minus 3i here and 1 minus 3b. It's a lot of manipulation here. Okay, so once this is done, what we're gonna do is actually just going to we are going to expand this. Okay, this is a square plus b square equals to 1 square. So we just try. This is 1 minus 3, that's why it's 5 marks. 1 minus 3b plus 3ai, and basically what we're going to do is actually multiply 1 minus 3b, conjugate sets minus 3ai, and just be very mindful of the manipulation here, minus 3i, after which you get 1 minus 3b minus 3ai. Okay, I am not, this part here, we have done this many times, so this is the conjugate will just add up, right? So 1 minus 3b square plus 3a square. Just remember that. Important. Helps a lot. So this is a 1 minus 3b. And after which you have got minus 3a square I plus b minus 3, 1 minus 3b I. And this part here will be, add them up. I square will be minus, but I'll just leave it as it is first. So then, there you go. So this part is alright, I think. Once this is done, we're just going to see how we can slowly manipulate out this, right? We only have a square plus b square square root is equals to 1. So let's see how this will pan out. Just slowly expand this part here. So it's a lot of things going on. So let me just write this out. I'll just expand. So once we expand it, it looks something like that. Let's just not forget that we also have a square plus b square is equals to 1. So I'm just going to fish out my a square plus b square. For that part there, for the one below, I can see that this is 9a square plus b square. So this will just be 9 times 1, the one below. So 1 minus 6b plus 9 times 1, right? So this is important. Now, then after which we are going to try and figure out the top part. So if you were to simplify the top part, what we get is 3 plus b minus o is minus of. So a minus 8a, this will cancel away. After which we have got plus I, 10b minus 3b square minus 3a square minus 3. Okay, so let me just check. This will cancel away this, and this will be minus 9a minus 9 minus 8. 3a square. Yeah, great. So this similar. This is actually just this over here is minus 3a square plus b square, which also equals to 1. So we can just gonna replace that in. Replace everything. This is minus 3 minus, so minus 6. So this will just be minus 8a plus minus 3 minus 6. So 10b minus 6. Okay, over 10 minus 6b. Great. Okay. So this case here, if you want to find the modulus will mean that we take, so this is actually, just let me slowly write this out. 10. So I say this is a 5-mark question, meaning likely to be tedious. I don't think it's difficult, but it's more like basically it's more like whether you can do it properly algebraically. So this case here, when you do square root here, is minus 8a plus 10 minus 6b. So this one here is b square plus 10b minus 6 over 10 minus 6b square. Okay, so once this is done, what we're going to do is actually just expand and hope for the best. So this part here, what I can do is actually the denominator, I could just leave it as 10 minus 6b square. This is 60 minus 8 square. Maybe I should just leave this whole thing here as move it over here. Okay, great, because I need some space. So once done, this part, what I could do is I just expand it. Okay, so this part will be 10. Okay, great. So just continue on. Here would be 64a square plus 100b square minus 120b plus 36 over 10 minus 6b square. Okay, the reason why I'm not going to expand the one below is because I don't think there's any way that which I will get a square plus b square, because the only value which I have is actually a square plus b square. So I'm going to leave it as it is first. Then after which I'm just going to express this as 64 a square plus b square. So if I take a 64 out, just bring a calculator, 64 easy to calculate, minus 600 minus 64 will be 36. So plus 36b square minus, okay, I think this we probably could factorize this b square minus 120b, oh, plus 36, this part here. Okay, so this will be 1. So 64 plus 36 will be 100. So what I'll get is actually just, let me just write this down nicely. So it's 36b square minus 120b, 64, 100. Okay, so this is 100. Over here, then this is 10 minus 6b square. Okay, so in other words, I am going to just, this is 1. Like I say, what I want is actually a square plus b square, because that would help me much in terms of simplifying it. So polynomial degree of 2, this would be 36 And then after which you have minus 120, 100. I hope for the best. So this will be, oh, this is a perfect square. Great, great. So this is, actually, this is, be careful. This is 3b minus 5. This is, but you have to be careful, okay? This is 3b minus 5 square times 4 in front. Because this is 36 in front here. Actually, you factorize the 4 out. So the bottom will be 10 minus 6b square. So this case here, once you're done, just be mindful of the expansion here. This is 2. I'm just factorize the minus 2 out. Minus 2, and after which we have b 3b minus 5. So this is actually quite factorize negative 2 out. So this will be 3b minus 5 square, and this would just be 4 over minus 2 square. Ta-da! So this one's done. What we could do is actually just cancel this off. So like I said, this question here, I don't think it's that difficult per se, but it's really tedious in terms of its working. Yeah, this is one. There you go. So this is how you do this question here proficiently. Any question or comments, please do let us know. Keep practicing and I'll see you in the next question.